This video covers exponents, but first we'll just have a quick look at how to do mathematics. Number and copy the examples and ask your tutor or teacher if there are any questions or any examples or steps that you do not understand. Number the questions, and unless you have the ability to get fit while watching someone else run, you must do the questions on your own before watching the answers. Mark your answers. If it is incorrect, write down the corrections. Make sure you understand where you went wrong. This will enable you to do better the next time you attempt a similar sum. Now in this video, we'll be looking at the exponential laws, and then we'll look at exponential questions that contain addition and subtraction, and then we'll look at questions that contain only multiplication in the denominator and numerator. Now just to recap on the laws, so law 1 states that if you have the same base, if you multiply the same base, the exponents add. So for a practical example, if I have x to the power of 7 times by x to the power of 5, then I simply add my exponent. So I get x is 7 plus 5, which is equal to x to the power of 12. Now for law 2 states that if I divide by the same base, I subtract my exponents. Now once again, and let's look at an example. Let's say we've got a to the power of 4 over a to the power of 3. So this means that I subtract my exponent. So I've got a 4 minus 3, which gives me a to the power of 1, or I can just write it as a. Now just to look at the algebraic fractions, how that works in the same way, where we'd normally say, okay, a over 4, a to the power of 4 over a to the power of 3. Now normally we just cancel out. 3a's cancels with 4, so we can expand it to a times a times a times a over a times a times a, and then each a can cancel with the top a, and then we are left with a. So this gives us the same answer, and this is just the law that you can apply to get the same results when you're working with exponents. And then for law 3, this one states that if you have a base to the power of an exponent, and that is again to the power of another exponent, then you multiply your exponents. So let's say we've got b to the power of 4, and that's squared. Then I multiply my exponents. Oops, that's b. So that's going to be 4 times 2, which gives me b to the power of 8. Now for law 4, and law 4 states that if I have the root of a number, it could be square root, cube root, I take my roots and I divide it with the exponent. So let's say we've got z. Let's say we've got z to the power of 9 and we cube root it. Then to simplify that, we just divide. So z to the power of 9 divided by 3 is equal to z to the power of 3. Now let's apply to something that we definitely know. We know the square root of 9 is 3. So if we take the 9 and we put it in its prime factor form, 3 squared, the square root of that. Now remember, we said that this is the square root. Now we don't write a 2. The 2 is just, if it doesn't have a 2, it's just square root. You should know that. Then we divide the exponent with 2. So 3 to the power of 2 divided by 2. So 2 over 2 is 1. So this is just 3 to the power of 1, which is just equal to 3. So that's just with the steps of our law 4 included to see that you will get the same answer. Now for the consequences of law 2, the first consequence will be that x to the power of 0 is 1. So this is a general law that you also always remember. You can have anything. You can even have 1,000 to the power of 0. That would still be equal to 1. And let's just look at why that is so. If I have, let's say, x to the power of 7 over x to the power of 7. Now, law 2 states that if I divide with the same base, I subtract my exponent. So 7 minus 7, and that gives me 0, so x to the power of 0. Now, we also know that if I cancel out, if I have the same numerator and denominator, I can cancel these two out and it will give me 1. So if I have x to the power of 7 over x to the power of 7, these two can cancel with each other and that will give me 1. So therefore, in general, if you have anything to the power of 0, that's equal to 1. Then for the second consequence is if you have x to the power of a negative exponent. If you have a negative exponent, you can take the base up or down and change the sign of the exponent. And once again, if we should look at, we know 1 can be, let's change that 1 into x to the power of 0 over x to the power of n. If we apply law 2 and we subtract our exponents, we've got x to the power of 0 minus n, and that is then x to the power of minus n. But you don't have to go through all of these steps. You can just use the shorthand method where you know if you have an exponent. Now, let's look at another practical example. Let's say that we have 1 over b to the power of negative 3. And if I want to change this, because we always want to end with a positive exponent. So if I want to change this into a positive exponent, I can simply take my base up and then my exponent, the sign of my exponent will change. So this then just becomes b with a positive 3 over 1, or I can just write it as b to the power of 3. So now for example 15, we have the following example. And now with exponents, where you apply laws, there's normally many ways to do it. So with this one in particular also, I'm going to do it in one of two ways. So first of all, let's look at the numerator. We have 4x squared y to the power of 36. Now, we can change this into 2 squared, but we also know if you know your squares off by heart, it makes it really easy, because then you know if you have, for example, 16, you can immediately take it out, it becomes 4. Otherwise, you have to put it in prime factors and see how it comes out. So we know that 2, the square root of 4 is 2. So I can immediately take these guys out of the square root. And also remember that when we have a square root, there's a small 2 there, we divide all our exponents with 2. Now this one's quite easy because we also know that x squared, the square root of that, these guys just cancel. That's pretty simple, that's just x. We can, but when it gets bigger, it's not always that obvious. So then we need to remember, okay, if I take this guy out, then I need to half my exponent. So first step, let's take it out. We've got 2xy to the power of 18, and that is over. So now this part, this is the part where this can be a bit overwhelming, a negative half. So let's start with putting our numbers in prime factors. So we know that 9 is 3 squared, so I'm going to write 3 squared x to the power of negative 2. That's the power of negative half. So all I'm going to basically do is apply law 3, where I just multiply in my exponent in the next step. So let's do that. We've got 2x y to the power of 18 over 3. So this is now if I multiply this out, this becomes negative 1. And then if I multiply this in, this becomes a negative, and a negative becomes a positive. And then this 2 over 1 will cancel with this 1 over 2. 2's will cancel, so I'm just left with x basically. So these guys will then cancel, and then this base can go up. So I'm going to take the base up, so that's then 3 to the power of positive 1 times 2 y to the power of 18. So just to simplify that, we have 6y to the power of 18. All right, now let's look at the next example on how to do this. So in this example, I'm going to treat this part as a base. And since this is negative, I'm going to take my base up. So this then, the first step is also still the same. We have 2xy 18, where we take that out. we times it with our base of 9x negative 2. This becomes positive half. So just notice that this negative 2 is still negative because this I'm just treating as a constant base. This sign will change because it's actually this exponent base that goes up. Alright, so then what we do is we can multiply in the half, or we can treat it, so this half, if I have x to the power of a half, this is the same as the square root of x, because remember this 2 just goes underneath the exponent of 1, the invisible exponent of 1. So we could either change this into a square root, or we can treat it as multiplying in the exponent. Either way. So in this case, I'm just going to multiply in the exponents. If we have 2x y to the power of 18 times by now, this is 3 squared. If we just write it in its prime factor form, x minus to the power of minus 2 power of a half. So for the next step, we've got this exponent going in, so 2 over 1 times by 1 over 2. The 2's will cancel, so we're just left with 3. And then multiply these two out, 2 over 1, the 2's cancel, I'm just left with minus 1. Alright, now 2 times 3, that gives me 6. Now x to the power of 1, adding minus 1, that gives me 1 minus 1, that gives me 0, and then y to the power of 18. So this x to the power of 0 becomes 1. You don't really have to put that step in, I'm just doing that so that you can see. So that's then 6y to the power of 18 as we have over here. Alright, so question 15.1. Now when I have a fraction and I have a negative outside the fraction, the first thing I do is to get rid of this negative is I just simply swap everything around and then change this to a positive, because that just simplifies things immediately. So I'm just going to rewrite it as 9xy to the power of negative 2 over 16x minus 3y to the power of 4, and that's all to the power of a half. Now just to make things clearer, let's say we had x over y to the power of negative 1. If I want to get rid of this negative 1 immediately, or let's just do the steps in between, we take the negative 1 into each of these bases, so this becomes x to the power of negative 1 over y to the power of negative 1. Now I want to change these into positive, so the base of x goes down and my 1 becomes positive, and then my y, the base of y goes up, and then my exponent of 1 becomes positive. So this is then y to the power of 1 over x to the power of 1. So this is just y over x. So that's basically what I did here. If I have a negative outside, I can just flip everything on the inside around. Alright, so now let's put everything in its exponential form, this 9 and 16, because the next step we're going to do is to multiply in this half. So this is then going to be 3 squared x y to the power of negative 2 over 4 squared x to the power of negative 3 y to the power of 4. Now if I multiply in the half, I have to take this exponent to each and every base. That means this guy needs to go there, 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 and even to the bottom parts. Alright, so let's start with that. So I know 2 times a half is 1, so that's going to be just 3. X to the power of a half. Then y, negative 2 times a half is just negative 1, y negative 1. And then we have just 4, because the half times with 2. Then x to the power of negative 3 over 2. And y to the power of 2, 4 times a half. And now we need to apply law 2, where we have the same basis and we're going to subtract our basis. So here we have to be careful, because here we're going to have to subtract a negative number. So if I have 3, and let's write it as 3 over 4, and my x value is half. Then I subtract a negative number, so minus 3 over 2. So now, just remember the law to put that negative in and then subtract whatever is at the bottom. Okay, and then we have our base as y, and we say minus 1 minus 2. So this then becomes 3 over 4. So this becomes a plus. Now this is 1 over 2 plus 3 over 2. So this is then 4 over 2. So this is x to the power of 4 over 2, and then y to the power of negative 3. And then we have 3 over 4. This becomes 2. So I'm just going to put this in fraction form again. So this becomes x squared, and my y with my base should go to the denominator again. So this becomes y to the power of 3. For question 15.2. Now, the first thing I want to do, I see a lot of x's and y's, so I want to put everything in exponential form. This is still in its root form, so the first thing I'm going to do is write x to the power of 1 over 3. Remember, there's an imaginary 1 there, so I can divide it with the 3 to put it in exponential form. Then times with y to the power of 1 over 3, doing the same here where, oh, this is actually a square root, so this must be 3 over 2. So I just took my imaginary 2 and I put it underneath the 3, so that gives it in exponential form. That's over x to the power of negative 2 over 3, y to the power of a half. And now this looks a bit complicated, although if we just remember our laws and just apply our laws with whatever we're given, it's not that bad. So I've got these same bases, and my law says if I divide my bases, I have to subtract my exponents. So x 1 over 3 subtract negative 2 over 3, and then times by y 3 over 2 subtract 1 over 2. So this is then this is going to add, so then I have x to the power of 1 plus 2, so that's 3 over 3, and then times by y, so I have 3 minus 1, so that's 2 over 2, and this then just simplifies to xy. Question 15.3. So now let's look at how we can start this one. So if we see here, we can immediately start by multiplying in this exponent. However, this is just equal to 1. And then also remember, when there's a negative, I'd like to get rid of the negative first. So I can just start off initially by just swapping these two around. So that's what I'm going to do first. I'm going to change this into a 1, and I'm going to swap these two around. And then over here, what we do to simplify this cube root is we're going to divide this 3 with this 9. So for the first step, I'm going to write the 2. So this became a 1, so I'm going to write the 2 at the top. That's 2, and then at the bottom I'm going to bring the x to the power of a half, the power of negative 2 down. So x to the power of negative 2, and then I change my negative over here to a positive. So don't get confused because this sign didn't change. The base went down because of this sign, not this sign. So just to get rid of this sign, I just swap everything as it is on the inside. And then times by, we've got x to the power of 9 over 3. Alright, so then I'm going to take my 3 inside to each and every base. So it goes to the top base and at the bottom. So this is going to be 2 to the power 3 over x to the power of negative 6, because my exponents multiply, times by, then 9 divided by 3 is x to the power of 3. So I can put this over 1, then it's easier to see that when I multiply this out, this will just then become 2 to the power 3, which is 8, x to the power 3 over x to the power of negative 6. Alright, so next step is we have the same bases over here, so we're going to subtract the exponent. So we have 8x to the power of 3 minus negative 6. So I'm subtracting a negative number. So I'm subtracting because of the same basis, and then I just write whatever is the exponent in brackets, and then I worry about simplifying it. So it's x to the power 3 plus 6, and this gives me 8 x to the power of 3 x to the power of 9. So that was laws. Now we move on to the addition of exponents. And first we're going to look at the steps. Now most of these questions, 90% of them, follow these steps. So the first step would be to apply law 1, and that means that you need to break up. We'll see what this means when we do the example. Next one is to factorize, then you cancel, and then you simplify. So those 4 steps will guide you through these questions. So for example 16, this can be sometimes overwhelming if you don't have the steps and you don't know where to start. So like we said, the first step is simply to break it up. So that means I'm going to take these 3's and break them up to be 3 to the power of n times 3 to the power of 2. See, that's the reverse of law 1, where if you have the same base, you add the exponents. And then that's over 3 to the power of n times 3 to the power of 4 minus 6 times 3 to the power of n times 3 to the power of 1. Alright, so now that it's broken up, we have we can factorize. That's the next step. That's factorizing. And see, you have to just look at this closer. This is one term and this is one term. So that means what this one is one term on its own, so we're not going to factorize the top part, but we can take out this from each of these terms. So if we do that, then we have 7. Okay, we can just copy the top part, times 3 to the power of n times 3 to the power of 2 over, so the 3 to the power of n gets factored out. So what's left is that 3 to the power of 4 minus 6 times 3 to the power of 1. And then the next step says we cancel. So this and this just simply cancels. And then we just simplify. So that means we just put what's left here into the calculator. This is then 7 times 9 over this would be 81 minus 18. And then if we put this into the calculator, so this is 7 times 9 over 81 minus 18, and that gives us 1. So now for question 16.1. So our first step was to break it up. We've got 5 to the power of x times by 5 to the power of 1 minus 5 to the power of x over 5 to the power of x plus 5 to the power of x times by 5 to the power of negative 1. And that's then equal to, so now the next step was to factorize. So if we see here, this is our one term, our other term, one term and another term. So we take out from each term a 5 to the power of x, so that comes out 5 to the power of x, and then what's left is 5 to the power of 1 minus 1. Because this entire term goes out, there's a placeholder that's left, over 5 to the power of x. And then if we take these guys out, we're left with 1 plus 5 to the power of negative 1. So these two will cancel, and then what's left we can just put onto the calculator once again. So this will give us 5. So let's just put our fraction there. We've got 5 minus 1, so this is just 4 over 1 plus 5 to the power of negative 1. So this is 10 over 3. Now for question 16.2. So first step, we break it up. 3 to the power of 2 times by 3 to the power of x minus 4 times by 3 to the power of x all over 2 times 3 to the power of x times by 3 to the power of negative 1 plus 3 to the power of x. So then we factorize. We've got 3 to the power of x that comes out, and we're left with this 3 squared minus 4. If we take these guys out, and then in the denominator we have 3 to the power of x. 3 to the power of x comes out, and we're left with 2 times 3 to the power of negative 1 plus 1. Then we cancel, and we put what's left onto the calculator. Now we have 3 squared minus 4, so that's 9 minus 4, which is 5, and then 2 times by 3 to the power of negative 1, and that is added to 1, so this gives us 3. Question 16.3, we have, okay, so now we have a 9 and a base of 9 and a base of 3 here. So the first thing I'm going to do is just to change these, this 9 and this 9 also to the same base of 3. So just going to rewrite that as 3 times by 3 squared. I'm just replacing it in brackets for now. Plus 1 plus 2 times 3, 2x plus 1 all over 4 times 3 to the power of 2x plus 1 minus 3 times 3 squared to the power of x. Okay, so then I'm going to just simplify this by multiplying out my brackets. And remember, we multiply the exponents, and that means we need to multiply all of this exponent to the inside exponent. So we have still 3 times, so this becomes 3 to the power of 2x plus 2 plus 2 times 3 to the power of 2x plus 1. That's all over 4 times 3 to the power of 2x plus 1 minus 3 times 3 to the power of 2x. All right, now we can go ahead and start with our normal steps. We've got to start by breaking up. We've got 2x times by 3 to the power of 2 plus 2 times 3 to the power of 2x times 3 to the power of 1. That's all over 4 times 3 to the power of 2x times 3 to the power of 1 minus 3 times 3 to the power of 2x. Next thing we can do is we can factorize this out. So we're going to take this term out from each term. We have 3 to the power of 2x, and then what's left is 3 times 3 to the power of 2, so that's 3 times 3 squared, plus then what's left here is 3 times, or 2 times 3 to the power of 1, and that's over. So here we take out once again 3 to the power of 2x, it comes out, and then 4 times 3 to the power of 1 minus 3. So these guys will cancel, and we just type in what's left. So we have 3 times 3 squared, which is 9, and then plus 2 times 3, that's 6, over, that's 12 minus 3, 12 minus 3. So this is 11 over 3. And that was addition. We move on to multiplication. Now steps once again. So the first step you want to do is to prime factorize. Then apply law 3, and then we apply law 1. So we prime factorize, then we multiply all the exponents into the brackets. Then we apply law 1, where we group the same bases, and then we simplify. So let's look at the first example, see what all of this means. So with your exponent sums, like I said, we've just worked through 3 types. So you have to, the first thing you have to do when you get to an exam is to recognize what type it is. So the first one is quite random. Like you saw when we applied laws, they can come in all forms and shapes. The second one will normally have a plus or minus in between your terms. This one in specifically with the multiplication, there's no plus or minuses, it's just multiplications. So with this, let's follow through on the steps. The first step was to prime factorize. So we would say we prime factorize 10, so that's 2 times 5. And if you want to know how to prime factorize, if it's a bigger number, with your calculator, let's say, for example, yes, this one can do it. So let's say we have, let's put it over here. Let's say we have 200. We want to put it into its prime factors. We say 200 equals, and then it appears, and then you say shift fact. Then you put it in its prime factor form. These, on the other hand, are quite easy, so we won't be using the calculator for this. 4x minus 1 times by 2 to the power of 3 to the power of 1 minus 2x over 2 squared power of 2 plus x times by 2 to the power of 4 1 minus x times by 5 squared to the power of 2x. Alright, now next step was to multiply in the exponent. So this then this exponent goes to each and every base. So let's start with doing that. So we have 2 to the power of 4x minus 1 times by 5 to the power of 4x minus 1, then times by 2 to the power of, now this goes to each and every term, 3 minus 6x, and that's over, so this one multiplies out, 2 to the power of 4 plus 2x times by 2 to the power of 4 minus 4x times by 5 to the power of 4x. Alright, now we've multiplied it in. Now for the next step, we have to group the same bases. So you can see we've got bases of 2's and we've got a base of 5's. Now simply grouping them, we write down the 2, and then we start by adding our exponents. We add the exponents that's on top and we subtract the exponents that's at the bottom. So we say 4x minus 1 plus, so there's another 2, 3 minus 6x, and then we subtract these guys and we say subtract 4 plus 2x, very important that you put your brackets, and then minus 4 minus 4x in brackets. And then for the 5's, we have 4x minus 1, subtract 4x. Okay, only reason why we wouldn't have to put brackets is if it's one term and it is a positive term. All other scenarios, if it's more than one term here or if it's a negative, definitely put brackets. Okay, and then we just simplify. So I can add these so long. I've got 4x minus 6x, that gives me 2 to the power of negative 2x, minus 1 plus 3, that's plus 2, and then I can multiply out these brackets. This becomes minus 4 minus 2x. These multiplied out becomes minus 4 plus 4x because I'm multiplying a negative with a negative. And then 5 ones 4x and 4x will cancel. It's left with minus 1. I'm just going to continue here at the top. So this goes on here. We have these, so we have these terms that we can still add the like terms, minus 2x plus 4x, that also will cancel out. And then the constant terms, we've got 2 minus 4, so that's minus 85, subtract, and then plus 2 is minus 6. So this is 2 to the power of negative 6 times by 5 to the power of negative 1. So this goes down and it becomes, so if I've got a negative exponent, I can take my bases down. 2 to the power of 6 times 5 to the power of positive 1. So this I can put on the calculator. This will be, I think, 64 times 5 or something. So we'll have 1 over 2 to the power of 6 times by 5. So this gives me 1 over 320. So 1 over 320. So for question 17.1, we start off by prime factorizing. So 12, that's 4 times 3, which is 2 squared times 3. And then to the power of n plus 1, times by 27, that is 3 to the power of 3, to the power of n minus 2 all over 18, which is 2 times 9, so it's 2 times 3 squared to the power of 2n minus 1. Alright, now next step, we multiply our exponents, so that's 2 to the power of 2n plus 2. Be careful to if there's a square and you take your exponent to both of these, so 2n plus 2 times by 3n plus 1 times by 3n minus 6 all over, so it's 2 to the power of 2n minus 1 times by 3 to the power of 4n minus 2. And then we group our same bases, so we have a base of 2, and then all our 2's put together, 2n plus 2 plus, oh, there's just another one here at the bottom, so we're just going to subtract 2n minus 1 times by, and then all my 3's, that's going to be n plus 1 plus 3n minus 6 minus, in brackets, 4n minus 2. And then we simplify. So we have 2, so that's 2n plus 2 minus 2n plus 1. This minus goes in, becomes a plus there, times by 3. So I can just add this along. This is 4n minus 5. Minus 4n plus 2 when I multiply my minus. And then simplify. So 2n minus 2n. Then we have 2 plus 1 is to the power of 3, and then for the 3 we've got 4n minus 4n, so this is then minus 5 plus 2, which is negative 3. To simplify that, I need to make this exponent positive by taking the base down, so I have 2 to the power of 3 over 3 to the power of positive 3. This is 8 over 27. For question 17.2, once again, start by prime factorizing, so that's 3 squared a plus 1 times by 3 to the power of 3a minus 4 over 3 to the power of 3 to the power of a plus 1 times by 3 squared to the power of a minus 2. Then we multiply out the brackets. We've got 3 to the power of 2a plus 2 times 3 to the power of 3a minus 4 over 3 to the power of 3a plus 3 times by 3 to the power of 2a minus 4. And then we group the same basis. In this case, we only have a 3, so that's pretty simple. So that's just 2a plus 2 plus 3a minus 4 minus the bottom ones, 3a plus 3, subtract 2a minus 4, 2a minus 4. And then we simplify. So these guys can add so long. So that's 5a. And then minus 2 minus 4 is minus 2. So multiply in the negative gives us negative 3a minus 3. Multiply in the negative gives us negative 2a plus 4. And this is then 3 to the power of, so this is 5 minus 3 minus 2. So these guys will cancel. And then we have minus 2 minus 3 gives me minus 5 plus 4 gives me minus 1. So make it positive, the base goes down, so 3 to the power of positive 1, and that's just 1 over 3. Now for question 17.3, we have 63. That's going to be 7 times 9, so that's 7 times 3 squared to the power of 1 minus n times by 7 n minus 1 times by 81, which is 3 to the power of 4 negative 1 all over 2 squared to the power of n plus 2 times by 36 is 6 squared. 6 is 2 times 3, so that's 2 squared times 3 squared. And then minus n minus 1. Alright, so multiplying the exponents, we've got 7 to the power of n minus 1 minus n times by 3, 2 minus 2n times by 7 to the power of n minus 1 times by 3 to the power of negative 4 all over 2 to the power of 2n plus 4 times by 2 to the power of negative 2n minus 2 times by 3 to the power of negative 2n minus 2. And then we group, so all our 7s, we've got 1 minus n plus n minus 1. And then we have our 2's, which is just going to be subtracted. So we have in brackets 2 negative, negative, and then brackets 2n plus 4 minus in brackets 2 negative 2n minus 2. And then finally for our 3's, just going to continue it over here. So that's 3. 3 to the power of 2 minus 2n minus 4 for that one. That's just plus minus 4, so it's just minus 4. And then minus negative 2n minus 2. Right, now simplify. So 7 minus n plus n cancels, 1 minus 1 cancels. So that's 7 to the power of 0. Then for the 2, we multiply out the negative. So you have negative 2n minus 4 plus 2n plus 2. And then for my 3, this can be added. 2 minus 4 is negative 2 minus 2n. This multiplies out, becomes plus 2n plus 2. And then further on, this becomes 1. Then, that's just 1. And then 2, so these two, minus 2n and plus 2n cancels. Minus 4 plus 2 is then to the power of negative 2. And then minus 2 plus 2n will cancel. And minus 2 plus 2 is also equal to 0. So this is 3 to the power of 0. So my final answer then, if I take this base down, this is just 1, so that just disappears. Or anything times by 1 is just the same. So this also becomes 1. So this is then just 1 over 2 to the power of positive 2. And then we have 1 over 4. And that was multiplication. And that means we've worked 3 exponents.